Okay, so we're looking at the homework for section 8.1 in Algebra 2, and in this section we're going to learn how to graph exponential equations. Now it's called an exponential equation because your variable is in fact an exponent. You see it's superscript really small up there. So I'm going to start with these x values and that equation, and I'm going to graph it. Now I'm going to do it first by hand, and your initial value is going to be 64. So right here, 64 is your y-intercept. Your starting number there will always be in front of the base. So 64 looks like it's about right there. And then if you multiply that by 1/4, which you would get if you used a first power, then 1/4 of 64 is 16. So we go out to 1, that's right here on this scale, and up to 16. So it looks like we're right about there. Okay, then at 2, you increase this to the second power and it multiplies it by another 1/4, and 1/4 of 16 is 4. So now out at 2 we just go up to a height of 4, and then at 3 it multiplies by another 1/4, and when you divide and multiply that by 1/4 you get 1. So when we're out at 3 here, you just barely get above the x-axis, and you get a 1 there. Now if you go the other way, we've been dividing by 4 each time. Excuse me, if you go backwards, you multiply by 4, and so 64 times 4, let's see what that gives us. 256, which is way up here off the graph. So we're ready to graph this thing. This thing comes down up like that, comes down through that point, hits that point, and flattens out against the x-axis, which acts as a horizontal asymptote. Okay, so here's the horizontal asymptote, and I'll spell that so you can see it. A horizontal there's a silent P, tote, asymptote. Y equals 0 is its equation, and it just helps you draw it. This thing gets closer and closer to that line as you go to the right. Now because the base, I forgot to fill in 256 here, hang on. Because the base is small, between 0 and 1, you're looking at exponential decay here. It's getting smaller as you go to the right. When that base is bigger than 1, it grows, and it will look like this instead. Okay, now let me show you how to conquer this problem just using the graphing calculator. You go to your y equals key and type in the function. If you're curious, the exponent key that I used is this little circumflex or caret key over here. And now I'm going to set up my table. So you go second and table settings here. You want to start at -1, going up by 1s. So now I'll go to my table of values, and here's these numbers that we used, plus some extras that we didn't use. And if you want to set up your graph here, you go to the window key, and this one goes from -2 over to about 3.5 in the x direction, and in the y direction it goes from -25 at the bottom to about 150 at the top. Now I'll hit graph, and here comes the picture, and you can find these points by tracing just to confirm it. So when you hit trace and 0, you'll see 0.64, and that confirmed our hunch that we've got an initial value of 64. That'll always be the y-intercept in front of the base there. 1 gives 16, that's this point. 2, when you hit enter, gives 4, and 3 gives 1, and if we kept going it would flatten out closer and closer to that x-axis, hence the asymptote. If you want to abbreviate horizontal asymptote, HA, you can do that. Now, none of this was asked for. All we had to do is graph and fill in the table of values. Okay, we're going to do another example of this. And first of all, I'm going to point out that when there's only a base written, you can rewrite this, and I'll do that first. And you'll put an a value of 1 in front, like that. Now that immediately tells me that the y-intercept is 1. So it looks like the scale here is about 2.5. It's a kind of unusual scale, but 1 would be approximately right there. Now what's happening is every time you add a number there, so for instance if I go from the 0 that I had to the 1, I'd be multiplying by another 2.5. So this thing's going to grow and grow and grow. It gets 2.5 times taller every time you move 1 to the right. Alright, so now we're just going to, let's just do this here. Take our y equals key and type in the equation. I have to use x instead of t. And I'll set up my table of values to start at -2 this time. And when I go to my table of values, I get 0.16 for the first value over here, which is really, really close to that x-axis. And then 0.4, which is hardly any higher. And then we get to the 1 that we've already graphed here. 2.5, you can see that's 2.5 times higher. And then if you take 2.5 times 2.5, you get 6.25, which should be somewhere about there. Again, the scale is pretty lousy on this one. And when you get a 3, you go up to a 15.6. Actually, we skipped, I made a mistake here. Okay, at 1, I have to back up here. At 1, there's 1. You go to 2.5, so this one was wrong, and so is that one. At 2, you get up to 6.25, and at 3, you're up at 15.6, so somewhere up there. Okay, so this thing comes through here like this and grows exponentially. You can see it getting taller as I go to the right. That's what exponential growth does if it fits this formula here. So all I have left here is to finish filling in this chart. 0.4, 1, 2.5, 6.25, and 15.625. Now each one of these is 2.5 times bigger than the one that was previous. So for instance, 2.5 times 2.5 gives this one. And when you take 6.25 times 2.5, you get that one. And that's why it's 2.5 times taller each time. And there's your graph. Okay, so that does it for the examples I've got for problems 1 through 4 on the homework.